Well, good morning, dear, and welcome back. So, this is April 28th, 2021, and we are, as you know, in a great crisis situation due to COVID-19. So, see, I am coming from outside and wearing mask. Now, two masks are needed. Okay. So, please remember whenever you go outside, wear mask properly. That could be your vaccine before you get actual vaccine. So, remember always. Well, so now let us start our discussion. The other day we were discussing about what fuzzy thinking is, what fuzzy logic is, and we just briefly introduced what fuzzy set means. And of course, we also discussed some history, who discovered it, and how it is useful, this multi-valued logic. And today we'll continue our discussion on fuzzy set, how to create fuzzy set. And before doing that, I would like to just tell you that fuzzy logic actually is based on possibility theory. Okay. Now there is a little difference between probability and possibility theory. In probability theory, which you have seen in machine learning, statistical machine learning, our outcome is not known, and we have past history, past data. Based on that, we are trying to predict our outcome. That is, it is measuring the likelihood of occurring an event. Whereas possibility measures the degree to which the outcome belongs to an event that does not have a well-defined boundary. That is, it tries to measure imprecision. Take the example of characterizing tall. Okay, say a person is already there, and I know what is her or his height is. Having known that, I am trying to predict that with what precision he is tall or he is short or he is average, like that. So this is possibility theory, where outcome is already known and you are trying to characterize it. So fuzzy logic is based on possibility theory. And you see, the other day we discussed that this is fuzzy set. Okay. Um, it has universe of discourse, say it is between 0 and 1, and if the membership value of some element in the universe of discourse of fuzzy set A is 1, that means X is totally belonging to A. If it is 0, then X is not in A, but if it is in between 0 and 1, that means it partially belongs to A. So how to actually capture this in a concrete form? That means how to fuzzify. Say, I would like to fuzzify a number 2. I'm calling fuzzy 2. Okay. So this is my membership value. Say it is between 0 and 1. Okay. And say this is my value 2, which is having membership value 1. Okay. Now I would like to, because you see why I am trying to fuzzify 2, because the number 2 may come from different sensor, right? Having some imprecision, right? So sensor will never tell you 2. I am just giving a rough example. Sometimes it will measure 1.9, 1.5. Well, if it is sensor is virtual sensor, and it means something more uncertainty. If it measures, then it could vary, okay, from some value. So I am trying to capture, say, 0.5. This is 1. This is 1.5. Then 2.5. Then 2.6, then say 3. So within my universe of discourse from 0 to 3, it's my decision that I will define fuzzy 2 within universe of discourse 0 to 3, and having 1, 2, 3, 4, 5, 6, 7 elements, for example, having all the elements having some membership value. Okay, say it is having membership value some 0.25. It may have membership value 0.5. It may have members 1.5, may have membership value 0.6, like that. 2.5 may have membership value. Okay. Uh, so 2.5 may have membership value, some value. Okay. So 2.6 may have some membership value. Rather, I should also make a one here and try to project it here so that it will be not clumsy. So you understand. And I am trying to create a set where um, so 0.5, which is element in the universe of discourse. My universe of discourse is 0 and 3. So this is my X universe of discourse, and where the element 0.5 may have some membership value like this. Okay, 1 has membership value like this. Then 1.5 has membership value say 0.6, then 2 has membership value 1, then 2.5 say has some membership value, 2.5 has membership value 0.6. Okay, so 2.6 has some membership value 0.7, like that. Okay, 3 doesn't belong to class 2, so it have membership like this. So this is my fuzzy set, which is describing fuzzy number 2. So fuzzy 2. So here the beauty is, you see, although I know this is the candidate most, that's why its membership value is 1, I am not ignoring in and around values of 2, because those have some relevance, right? That is the way I am measuring the imprecision in a democratic way by incorporating all these uh, neighborhood elements of 2, giving some membership value, which I get by defining a membership function. So similar could be the case for defining fuzzy, say 3. So you could define in and around 3 many numbers like 1.5, 2, 2.5, 3.25, 3.5, 4, like that. Okay. So, and you can attach membership value, and then you can create a fuzzy 3 like the way we have created. Okay. And each actually value gives you some concrete result. So this is fuzzy 2, and if I try to know that what does it mean, that I can add them together to get 2, that is 1.5 is giving me sorry, this is giving me this length, okay, plus this is giving me this another length. So these these, these I can add together to get fuzzy 3. Okay. So this is simply how we can fuzzify and create a fuzzy set, okay, of um, some you see variables, okay, right. So you see also now you will understand that coming back to our um, tall man example, say this is my quiz set, and there are some values like 180 belongs to average, but moment you put it 180.1, that will be classified as tall. Okay. Similarly, 170 is average centimeter is average height, but the moment you give 169.9, which is almost 170, it will be classified as short. So this is not acceptable. This is what this set is doing. On the other hand, you see fuzzy, uh, I have membership function like trapezoidal, which is describing short. Then I have defined another membership function triangular, which is describing average, okay, and another membership function which uh, characterize tall. So these are the creation of experts, okay. Taking opinion from expert, we have created this membership mm, functions, so that now you can see a person having height this, okay. So it will be belonging to uh, average class with this value. If you project that in tall, it will belong to the category of tall with this value. And you take both so that finally you get a more concrete characterization of the value of, say, 184 or something like that, which I have selected. Similarly, say anything here, okay, element in the fuzzy set will have some values. It belongs with that membership value, it belongs to the category of average. But if you project it further, it belongs to the category of sort with that membership value. And then if you incorporate both in your fuzzy set, then you better characterize that what actually the person's height is. Okay, so this is actually fuzzy thinking, right? Fuzzy set. So you can develop a fuzzy set in a more general way. Say this is universe of discourse, and you have elements x1, x2, x3, xn, and each element has some membership value. So I can create a fuzzy set, okay, for fuzzy set. Uh, so x1 attached with, say, membership value mu1, x2 attached with membership value mu2, x3 attached with value mu3, right? So xn mu n, like that. So this is my set. It could be any number that you will have to decide. Fuzzy set A. So what you see that every element here is a tuple, right? So the elements with attached with its corresponding membership value, element corresponding membership value. In some literature, you may figure out that they put the membership value first and then the element next. Okay. Anyway, so there has to be attached like this. Okay. So basically, they are the same. Okay. And I can use very the very good method to represent, create such set. I told you how to create, and then you can represent after creation of such set. You can represent in the computer using, for example, array, two-dimensional array. Uh, you can develop, you can store fuzzy set, and then once you store them, then we can manipulate, which we are going to discuss next. But you see, fuzzy concept of fuzzy set also can contain hedges. Hedges are more finer um, uh, fuzzification of some elements. You see, for example, the earlier example, this was our earlier characterization of sort, then average, and then tall. Then we had some edges. If this is short, then let us suppose we are calling it very short, okay, by this. Then we are calling it very tall, like this, okay. We can also do very average, like this, okay, very average, okay, like this. So, and researchers have figured out what will be the nature of this function, like you see, what will be the, so they have characterized very, very by this, okay, membership value to the power 4, more or less root over of membership value x with a, somewhat root over of this. So indeed, a little, slightly, very, extremely. So these are the research results of uh, fuzzy logic researcher, and we can use it for our um, purpose if we need to um, define our fuzzy set more precisely so that it can more concretely um, capture the vagueness of the nature. Let us give me a concrete example. Say I'm sitting over Triple IT Allahabad, and this is May. So if I tell it is hot, so you can understand this temperature is in between 40-41 degrees. But if I tell, oh, it is very hot, okay, you can easily jump. It is not very normal. So maybe temperature is um, 20. 45, 46, like that. Okay. So Hedges tries to um, more concretely um, represent the imprecisionness of the fuzzy variables, right? And that is useful, as I gave you the example. Now, once you know how to create fuzzy set, how to represent them in computer, and then how to make more precise fuzzy set, you adding hedges, right? Hedge is coming from, what hedge means literally. So we are adding more precision in our, giving more expressive power, more concrete expressive power with our fuzzy variables, right? Having knowing all these things, then we'll talk about some operations on fuzzy set. You see, if they are crisp set, Cantor's sets are operations are very much known, right? Say if A is a set, then not A, that is complement, is outside whatever elements are there. Okay, in this universe of discourse is representing not A. Then containment is actually between A and B. You see, you see this is containment. The intersection, you see, this is what intersection is. Union, you see, union is, right? So this is union, which is actually, so this was the operations with crisp set. In fuzzy set, you see, if this is our fuzzy um, fuzzy set with this membership value, triangular membership value, then complement of this will be this set. Okay, so it is just um, inverted, triangular members. So as I said, A complement of that set is this one. Okay, similarly intersection, you see, this is what intersection is, and it's depicted by this. Similarly union is, you see, these are all very straightforward. So this kind of operations you can do. You can uh, once I represent them in the computer, then I can see two sets are there, elements are there, and I am looking for common elements, and creating another set which will be our intersection, for example. Then I am actually taking all elements except a repetition, then they will be giving the union I can create. Okay, and very easily in the computer we can create all this. Okay. Now let me tell you some very important aspects of fuzzy uh, arithmetic operations. Okay, so we are trying to um, do some arithmetic with fuzzy numbers. In that context, I will give you example with fuzzy addition, fuzzy subtraction, fuzzy multiplication, fuzzy division, and I will concretely discuss more on fuzzy addition because all other are very straightforward once you understand the addition part. Say I have two fuzzy set A and B and I'm trying to add them, right? This fuzzy set could be fuzzy number, okay? So how to do that? First, I'll have to calculate the minimum of um, the membership values of for each element in the to set, and then I will see uh, if there is any repetition. If not, then take the maximum um, of the elements membership value. So this doesn't make much sense unless I take a concrete example. Let us do that. So I am referring again, I have rewritten it. So this is your max, this is your mean. So you see, say I have two fuzzy integer a, which is defined as one element 1 with membership value 0.3 plus another element 2 with membership value 0.6 plus 3 with membership value 1 plus 4 with membership value 0.7 plus 5 with membership value 0.2. So this is my uh, fuzzy set in and around 3 has been built like this. Let's take an example. Let us assume that. Another fuzzy integer b in and around 11 has been defined like this. 10 with a value, membership value 0.5, 11 with a membership value 1 because it fully belongs to set fuzzy integer 11, and 12 in the vicinity of 11. 12 is another which I have taken. I can add more. Okay, 12 with a membership value 0.5. Say, so these are the two integers, fuzzy integers. They are not um, ordinary fuzzy integer. Now I need to sum them together. Okay. So some intermediate step, you see how to do that. Now each element with its corresponding membership value has to be added. Each element of set A to be added with each element of set B. Say one by one. Take this one. Okay. So add with this. I get 10 plus 1 equal to 11. Okay. And what will be the membership value? It is telling you minimum. Okay. So minimum of the membership value 0.3, 0.5. Which one is minimum? 0.3 is minimum. So I do, after this operation, addition operation, I get this element with membership value, right? Then this to be added with this. So 1 plus 11, 12, and 0.3, 0.1. Which one is minimum? 0.3. So I kept this. Then it should be added with 12. So 1 plus 12, 13. 1 plus 12, 13. And then what will be its membership value? 0.3 and 0.5, whichever is minimum, as uh, the rule is telling. The rule has been actually can be deduced. I am assuming that you know this rule and we are following this rule. Our job is to understand how things can be, fuzzy addition can be done. Okay. So now take the next one. Okay. So we have got this. So I have used different color to tell you the contribution of all the elements in the addition process. Then we are taking this one and repeating the same thing. Okay. This to be added with this. So I have got 2 plus 10, 12. And out of 0.6.5, I will have to take 0.5. So this one is there. Then add this with this, add this with this. Okay. So 2 plus 11, 13 with this number plus 2 plus 12. So you got now, right? So in this way, I will have to continue for all the elements. Addition we'll have to do for all the elements in the fuzzy set 1. So this to be added with this, to be added with this, to be added with this, and it will give you, see, 10 plus 3, 13, and 0.5 plus 14 with membership value 1, isn't it? Huh? This plus this, and both have membership value 1, so 1 we have taken. Okay. So then this plus this, 12 plus 3, 15 with membership value 0.5 because I'll have to take minimum of the membership value first. Okay. Here. So in this way, I have created a fuzzy set, okay, uh, which is intermediate state of summation. Now you'll have to choose maximum of the duplicates to get the final result. Okay, duplication is not allowed. So then ultimately, what will be the addition between the two fuzzy integer a and b? It will be addition a plus b. Okay, that will be, you see, I'll have to search now in the set. And all this operation you can do in computer, right? Through program. So 11. Okay. 11 is 1. Is there any other 11? Let me see. 11, 11, 11, 11. No other 11. So I have kept this as it is. Okay. Then come to 12. So 12, 12, 12. Any other 12? Yeah, this is one 12. This is another 12. Is there any other 12? No. So out of this 12, I will have to take now maximum. Okay. So membership value. Which one is maximum? 0.5. So done. Then third come to 13. Such 13, 13, 13, 1, 13, 2, 13, 3, 13. Okay. And then out of these three, whose membership value is maximum? You see 0.3, 0.6, 0.5. So 0.6 stands. So I have included 0.6. Then 14. So like that, you have understood. 14, 1, 14, 2, 3. Three 14s are there, and the maximum membership value 1. So I have taken 1. So in this way, you have done the addition between the two fuzzy integer, and the result is this. This is another fuzzy set, you see. So you see, basically you see, you are adding 3 with 11 because both have maximum belongingness to their respective fuzzy set. So it will be 14, 1 plus in and around 14. So this is more precise, okay, it's a democratic way of doing the things. So this is about fuzzy addition. Once you know that the negation, fuzzy subtraction is also you can do, fuzzy multiplication and division also you can do, and those you will have to do as assignments. Also, I will now show how to calculate a fuzzy function. Say I have a function which is defined like this: y equal to x minus 3 square whole square plus 2. This is my function, this functional relation between y and x. But here x is actually is a fuzzy integer which has been defined in and around 4, for example, like this is given. Okay, so 4 having membership value 1. So in the vicinity of 4, you have another element of the set 3 with membership value 0.6, 2 with membership value 0.3, 5 with membership value 0.6, 6 with membership value 0.3. And the rule is, you see, you'll have to first calculate for corresponding to each element. Say, first element will be 2. So put x equal to 2. So 2 minus 3 square plus 2 equal to 3. Now, what will be the membership value? 0.3. Because 2 is a number having, so this is a tuple, right? It does not have any independent existence. So the moment you calculate y1, for example, which is another fuzzy set, okay, when you evaluate, it will be fuzzy set, so it has to have the membership value. And that membership value will be the independent variables membership value. And likewise, 3 you put here, and then you get 2 and take the membership value of 3, attached with 3, 6. And then like that, okay, you understand. This is third, this is fifth, okay. Now once it is done, say if as many elements are there, that many computation you'll have to do, and the elements will be like this. Now you'll have to choose maximum of the duplicates to get the final result, like the earlier one. Okay, so you'll have to figure out what is the duplicate. If duplication is there, choose the maximum one. You see, 3. Is there any other 3? 3, 3, 3. Yes, there is another 3. This 3 has membership value 0.3. This 3 has membership value 0.1. So this wins the contest. So it will be incorporated in the fuzzy set. which is we are getting by evaluating that function. Clear? Then 2. Is there any repetition of 2? No. So 2 will be as it is here. So we have got it. Then 6. Is there any 6? No. So as it is, it will be there. 11. Is there any 11? No. So as it is, it will be there. So after evaluation of this function, I will get again a fuzzy set, which is given by this. So you know fuzzy manipulation now. You know how to evaluate a fuzzy function. And then um, in the next class, we'll study that how to formulate fuzzy rules and how to rank out inferences, first with small inferences, and then how to write weekend rules to get inferences, and then we'll extend it to much more um, practical problems so that we can use fuzzy logic as a fuzzy inference tool. Okay, thank you for your attention, but uh, don't forget to wear mask when living, and stay safe with this mask, and have a nice day. Bye bye.